the mean value theorem, simple theorem to remember. You just got to remember mean is average rate of change, really big part about it. So the main idea is that somewhere in an interval, if our function is continuous and differentiable, the next video, the next section is really going to emphasize that it needs to be continuous, it needs to be differentiable, it needs to be both those things. But anyways, for us, the main part of this assignment is that the slope of the secant line, somewhere in the interval, the tangent line is going to have that same slope. In other words, if you look at this, and like I said, all these words up here going to be very used in the next assignment. For this one, this is the main part. Somewhere in the interval from A to B, notice that's the open interval A to B. So, and I'll show you why that's so important right now. But in that interval from A to B, somewhere within there exists a point C somewhere in between A and B. Like you see in this picture, here's A, here's B. Somewhere in between is a value C, such that the instantaneous rate of change is going to be equal to the average rate of change. Remember, this is the formula for the average rate of change. This represents instantaneous rate of change because that is the derivative. So going through this example right here, what we're going to do, we're going to use that same exact formula. We're just going to set f prime of C equal to f of B minus f of A over B minus A. Now the nice thing here, they gave us the interval from 0 to 3, so there's our interval. And we're going to look for C, whatever C is. So I'm going to go ahead and fill that in right now. F of 3 minus f of 0 over 3 minus 0. And let's just focus on that side for now. So what is f of 3? F of 3, well, we have our function up here. We just plug in a 3. And you'll get 27 minus 54 plus 36. Negative 27 plus 36. It's going to be 9. And then for f of 0, same exact thing. We just plug a 0 in. That's actually going to zero it all out in this problem. And so plugging that in, we're going to have 9 minus 0 over 3 minus 0, which is 3. Okay, what about f prime of C? So let's go ahead and cover that. So f of x is x cubed minus 6x squared plus 12x. So f prime of x will be 3x squared plus, not plus, minus 12x plus 12. So f prime of C will be 3 times c squared, just plugging in a c for the x, minus 12c plus 12. So that's going to go in over here. And you can really substitute that at any time for f prime of c. It's just easier to write it in that last step. So now we have a quadratic. So what we're going to go ahead and do is we're going to get it equal to 0 by subtracting the 3 to the other side. And so now what we'll have is 3c squared minus 12c plus 9 equals 0. Factor out the 3. And then we'll factor this, use the diamond method, c minus 3, c minus 1. So c equals 3 and 1. Now remember how I said the open interval. So what that means, if we look at our interval, and we look at this theorem right here, it's the open interval from A to B. So that means we can't include those values A or B. We're not going to include those endpoints. So we're looking at the open interval here. And so 0 to 3, we're not going to include 3. So our answer is going to be 1. It's going to be the other value. All right, let's take a look at one that's a little bit more difficult. Still the same process though. So we're going to do f prime of c equals, and we have our a and b right here, equals f of 10 minus f of 2 over 10 minus 2. So what is f of 10? Let's start with that. So f of 10, or I should be using g. because this is using g of x instead. Not a big deal. But it's just called g of x here, so that's why I want to call it g to be a little bit consistent. So that's 4. And then g of 2, you could see is 0. Kind of works out nicely. So 4 minus 0 over 10 minus 2. It's 4 over 8, which is 1/2. All right, let's go ahead and take care of the derivative. So g of x is square root of 2x minus 4. So that's 2x minus 4 to the 1/2. So let's go ahead and take this derivative. So g prime of x, bring down the 1/2. Gonna have to do chain rule. Take away 1 from the exponent, and then chain rule times 2. So remember that's 2 over 1. These 2's will cancel. And what you'll see is that we end up with this on the bottom as 2x to the minus 4 to the positive 1/2. So we'll just change that to the square root. So g prime is c. We just replace that x with the c. That's it. Trying to fix this up a little nicer. Okay, now that we're here, what we're going to go ahead and do is we're going to cross multiply. So we have a fraction equal to a fraction. So the best way to go about this is to cross multiply. So what's going to happen is we're going to have square root of 2c minus 4 equals, because that's times 1, and then 2 times 1 is 2. So just a little cross multiplication. Then we're going to square both sides. So we'll get 2c minus 4 equals 4. 2 squared is 4. Add the 4. 2c equals 8. Divide by 2. And c equals 4. And there's our answer there. And that's the process. The main thing is this formula up here. This is the mean value theorem, that the instantaneous rate of change is going to equal the average rate of change. Somewhere in that interval it's going to equal. That's the main part. From there you just fill in the derivative equal to the average rate of change and solve for it. And that's it.